Good afternoon. Welcome to Materials and Methods. We're going to discuss framing methods today during class. Okay, first off, I want to review what our learning outcomes are going to be for this section and also talk about assessment. We're going to be defining articulating differences and similarities of our framing methods. We're going to communicate use of best practices, articulate the concepts of green building and sustainability. Demonstrate the ability to perform the various framing methods, and our assessment. How I'm going to judge it at the end of the section is we're going to actually have a project in our materials lab. We're also going to do some review questions. There's going to be some reading involved, and then once we looked at all the different methods, I'm going to give you a quick quiz. We're going to go through a little bit of an exam to assess how well you picked up the materials. So, any questions about what we're looking to learn, or how it's going to be assessed? Very good, let's get started. All right, introduction to framing methods. First off, our framing has to withstand two types of loads, live loads and dead loads. Dead loads are stuff like the framing material, they're the wall materials, they're permanent fixtures within the structure, they're static. The bathtubs, vanities, and I'm going to call kitchen cabinets in there too. We don't move them around, so we have to take into account that those permanent loads are going to be assessed or be involved. Our live loads are things we move around, dressers and beds and tables and people. People are live loads too. So just a little bit of background there. We've talked about it a little before, but we have to, in our framing of our structure, take those into account. So let's talk about those various methods that we're going to use for residential and light commercial structures, framing methods. The one we're talking about today is going to be platform framing. Others that are out there that are and have been used, balloon framing is one of them. Balloon framing was very popular from about 1830 to probably about 1930, and then we started getting into more what I'm going to call traditional or current types of framing, platform framing. But balloon framing was about that area, about 100 years of that era. Post and beam framing, that came on about 1620. That was one of our original methods of framing. Barn framing, a lot of barns were framed out of post and beam, but we also did it for residential and light commercial structures too. And A-frames are more of our vacation homes. A-frames are using the walls and are using these heavy beams or heavy structures for both wall and roof members. So they double. They have a double duty there. So, here's a general concept of a exploded balloon or a platform frame structure. This is the most common framing method we use today. Also referred to as Western framing. Now, when I talk about most common and most popular, we're talking wood frame structures. We're not going into masonry and things like that. We're talking wood frame structures right now. Why do we use it? It's efficient, it's cost effective, and cost-effective method of assembly, easy to erect. So there's a lot of benefits to our platform framing. Any questions? Questions so far? Okay, let's move on. So here's a typical wall section for a wood frame structure, platform frame structure. Now I know it's a little difficult to read, but I'll walk you through it. Starting at the top, working down. We're looking here at what we call where our roof rafters meet. We have a main support up there. We call that a ridge beam. But this assembly here, our ridge beam, our rafters, which this is our rafter here, and our ceiling joists, we either stick, as we call stick build, or build them on site, or what's most commonly used now, we use truss systems. So truss systems really have come on board. They're fast, they're pre-engineered, you don't take nearly especially enough time, so we can get this structure under roof and protected much quicker, much faster. So some areas of the roof we still have to stick build. When we have those complicated and those very involved roof sections that come in at different angles, we need to still do some of this stick building. So we have two sections. We have a wall section here, wall section here. I'm going to jump ahead, we'll come back. These are our typical wall assemblies. Now this is incorporating door and window, and also does some interior wall nailers or some bracing. So, but these are the kinds of things you're going to find in a typical wall assembly in a wood frame structure, platform framing. Bottom plate, double top plate, studs, some of the other elements in here, but typical wall framing. Okay, coming back here, that's these sections in here. Now, we're showing a slab on grade situation with a grade beam. Talk more about that when we talk foundations. But in here we have our second floor, and we're using a rib joist along with traditional floor joists that go across into here, and those are our main floor structures. Okay. Typical wall section in here. Something unique at the bottom. Typically, when you see a wall frame system like this, it's built on the deck, raised up into place. I've seen both ways where we use a sill plate, which is a bottom board. It separates the foundation from the other assembly. Okay, treated, so no, for decay. But what's also incorporated in this sill plate assembly is a sill sealer that goes between the foundation and that sill plate in order to take up any voids or misgivings in the foundation. But then also, we need to incorporate a termite shield. We need to make sure those critters don't get up into our wood. And then, of course, anchor bolts to tie it all together. So, this is our typical wall framing. This is what's going to happen here, the different assemblies here. I want to cover some other things, so we're going to move on. Here's our typical wall assembly. Now, is there any questions? Can I answer any questions with regard to our traditional platform framing, this typical wall section, or our typical wall framing? Okay, traditionally done 2x4 dimensional lumber. We all know 2x4 dimensional lumber, actual size, 1.5 by 3.5. Okay. Okay. Platform framing, the new standard in framing. I want to take a little time and talk about the new standard in framing. Our new standard is going to emphasize energy efficiency. It's going to talk about tightening the envelope, which includes pressure boundary and thermal boundaries. We talk about this in the home performance section. Okay, we're going to talk about how we make those align and what we have to do to make them work together. We're talking more about our framing right now, our platform framing. So we're also looking at using better building techniques. As you can see here, we have somewhat of a foundation. In North Carolina, our frost line is 12 inches. So the International Residential Building Code says that our footing has to be down at least 12 foot in grade in order to meet code. So here we have a footing along with a small concrete foundation wall that actually slab comes up to it. But here, look, we're incorporating insulation into that. Okay, our wall assembly includes a better weather barrier, and with this new standard, we're using 2x6 framing rather than 2x4 framing. 16 inches on center. In some cases, we're going to go 24 on center. We'll discuss that in more detail. Okay. Better building techniques, measurable through diagnostics. When I talk about that, I'm talking about, or what the standard is now we're incorporating the International Energy Conservation Code. Most have adopted 2012. Okay, this code is focused on simulation-based compliance. So the code is measured here again through diagnostics. All right, the International Energy Conservation Code has a lot of parallels or a lot of similarities to the ASHRAE code. And ASHRAE stands for the American Society of Heating, Refrigeration, and Air Conditioning Engineers. They're 90.1-2012 code 2. So there's a lot of similarities when we talk about home performance and building performance and how we go about building and framing. Okay? Any questions either on the International Energy Compliance Code or on ASHRAE? Okay, let's move on. The majority for this push for energy efficiency, this new drive for green building and sustainability, took place based on the American Recovery and Reinvestment Act back in 2009. So that's really where this really got its momentum to be smarter in our building. Consider our building the same way as we kind of consider our body. You know, we have different assemblies, we have different layers of protection, we have different types of mechanical equipment, different types of utilities. Our body has the same. So if we don't take care of our body, it breaks down. Same thing with the house. If our house isn't running right, just like our body doesn't run right, it can break down. So here's an example on a standard foundation. Here I also have an example of what you would see on that grade beam that we saw when we were looking at that typical wall section with the 2x4, the traditional platform framing. We're moving away from that, folks. We're moving away. It's going into energy efficiency. It may not be great extremes. All depends what the homeowner is willing to pay for it. But now we have to be code compliant on certain areas of this. So now we're going to look more at 2x6 construction. We're going to be sealing the holes better. Our insulation requirements are going to be greater. So those are all things we're going to discuss. Right now we're concentrating on framing. Any questions? Questions so far? Okay, still looking for questions? That's what we've discussed right now is an introduction into platform framing, okay? At this point, what I traditionally do is if I'm done with my day's lecture or presentation, I'm going to go ahead and ask for questions, but then also I'm going to identify what our assignment is for the next time we meet, whether it's homework, chapters, or outside projects. So I appreciate you listening and watching.